Turbo! What's up, Turbo community? I'm Jonty. I created this cute time-based simulation game called Dreamland in the Turbo engine. In Dreamland, the player uses their mouse to fill vials of sand to give to sleepy dreamers to help put them to bed. In this video series, I'd like to show you how I created the mouse functionality for the UI elements of Dreamland so that you can adopt or modify them for your own game. This video will be covering mouse input, hover states, and traits in Rust. If you're not familiar with the Turbo engine, we have other great videos to watch to get started. I am going to be starting from a blank file though, so you can follow along and by the end have working UI in Turbo. So if you have Turbo installed, I'm going to head over to Visual Studio Code and start coding. So starting fresh, I'm going to open up the terminal in my VS Code and init a new project called Turbo UI. Great, and now that that's created, I'm going to open the folder and then open the lib rust file here. Great, so this is your blank file. This is where we're going to be starting. Just once again in the terminal, I'm going to use the turbo run command -w so that we can have a hot loaded version of the game displayed while we're working on it. Hello world. Okay, awesome. All right, and to start off, I am going to use the other turbo command init to declare our game state. So struct game state, and in here we're just going to track one variable for now, call it toggle, and it will be of type bool. And then we will initialize our struct, and we will initialize toggle with a default value of false. To finish this up, I'm going to go into our go loop and create a mutable variable called state and set it equal to our game state struct function load so that any saved data is loaded recursively every frame. And then at the end of our go loop, I will call state save. Okay, great. Now we have our game state functioning in our turbo loop. So the first thing I'd like to do is to get a little functionality out of this bool that we're tracking in the game state. So right now in our go loop, all we're doing is drawing some text into our game window. But I would like to draw a different string when the boolean is true. So I'm going to create a new if statement, if state toggle. And in here, I will put our other text. It will be good night world. And then I'll create an else statement, and I'll just move the original text into that else statement. So if I save this, we'll see no updates over in our game window because we have not toggled the toggle boolean to true. It's default to false. So let's change that by allowing the player to toggle the boolean. So to start, we're going to capture some input so that we can register when the player clicks. Starting off, I'm going to declare a variable called m and set it equal to mouse0, which is Turbo's way of reading mouse input. And while we're here, I'm just going to create two more variables, mx and my, and set those equal to m position. And so this way we have the overall input of the mouse as well as the individual integer values of its position within our game window. Okay, great. Now that we're registering these things, I'm going to create a new if statement so that we can register when the player clicks. And we can do that simply by saying if m left, which is the left mouse button, just pressed. And this function returns true when the mouse has just clicked. So when this is the case, we will say state toggle equals the opposite of state toggle. And if I save that and come over to our play window and click, we'll see, great, we're toggling that bool from hello to good night and back again. So we have some mouse input in our turbo game now, but let's say you wanted the player to click only in a specific area instead of anywhere in the game window to toggle this bool. So that's what this video is mostly about. We will create a new struct called UI button, and within that struct we will define how it is created and drawn, and then we will create a public trait which will be universally inherited by any kind of struct that you create that you want to be able to be interacted with the mouse. So starting off with our UI button, I'm going to go beneath the turbo go function and create a new pub struct called UI button. And with this struct, since we want to be instantiating it within our turbo scene, we have to include some derived properties that it's currently not deriving. So to do this, I'm going to say pound derive debug clone partial equality borscht serialize and borscht deserialize. Okay. So now that we have those derivations, we can define our button. And we're going to define a few variables that we're going to use to help construct it, starting with a variable called hitbox, which will be of type tuple of 4 integer values. And these integer values represent the x, the y, the width, and the height of our button. Okay, great. The next variable that we're going to want is going to be a variable called text, which will be of type string. And the final variable that we're going to want to track is called hovered, and it will be of type bool. So now that we have a new struct, we're going to implement that struct so that we can create some custom functions for it. We say implement UI button, and the first function we're going to create is going to be called new. And we're going to pass in a few parameters here to help with the construction, starting with a variable called text, which will be a reference string, a variable called hitbox, which will be the same tuple of 4 integer values. Okay, so those are the two parameters that we're going to want whenever we're constructing a new button. And then this function has to have a return type of self. And if we open this up, similarly to how we declared the game state, we are going to declare a new self for this function to return. And so to do this, we just have to create default values for our variables that we're tracking. So for the hitbox, you could type in these values manually, but since we are passing in a hitbox variable, we can say hitbox is going to be equal to that hitbox variable. And then, because this parameter is named the same as the variable that the UI button is tracking, we can even simplify this more by removing the colon and just saying hitbox, comma. Moving on to the text, we have to do some string manipulation so that we can't simply do the same solution. So we will say text to string, and then finally our hovered bool we are going to set as a default of false. All right, so now we have a constructor. We're going to need one more function so that the button is actually drawn in our game window. So we'll create a new function called draw, which is going to take in a reference to itself so that we can access all of the variables that we're storing up in the UI button. Okay, there are a few things that we need to do to draw the button, and I'm just going to move through them fairly quickly here. So to start off, I'm going to declare a couple of variables that we're going to use to color our buttons. So let C1 and C2, these stand for color1 and color2, and they are of type unsigned integer, U32. And I'm just going to copy over some hard-coded values. So 0x, 32, 3b, 42, ff. This is a dark gray color. And 0x and 8fs, 1, 2, 3, 4, 5, 6, 7, 8. This is white. So these are the two colors that we're going to use to draw our button. And then coming down below it, I'm going to first draw the rectangle of the button using the turbo command rect and passing in our hitbox variables. So x equals self hitbox 0, y equals self hitbox 1, width equals self hitbox 2, and height equals self hitbox 3. And then for the color, I will say color equals C1. And then I'm going to use the turbo function text to draw some text onto our button. And this is going to be a reference to self text as the first parameter. And then for now, I will just set the x and y to self hitbox 0, self hitbox 1, and then set the color to C2. This is enough for now to draw our button. Now that we have our button defined, we're going to go back up to our game state and create a new variable to create a button. We will call it button. It will be of type UI button. And then we need to create the button by saying UI button new. And the text we will use on our button will be continue. And the first tuple that we will pass is going to be x equals 90, y equals 44, with a width of 75 and a height of 30. And the last thing that we'll need to do before we can see our button is come into our go loop and call state button draw. And now if I save this, we'll see over here, we're drawing our button roughly in the center of our screen. Still don't have functionality out of it yet, because I can still click anywhere on the screen, but we're at least keeping track of this button element and drawing it on screen. One last thing I just want to do for our button's visuals is the continue text is currently being drawn in the very top left corner of our button, and it would be much nicer to have it centered inside of our button. So I'm going to create a couple of variables to replace the x and y values in our text argument. So I'm going to declare x and y. So for the x value, we're going to start at the button's x value in its hitbox and add half of the hitbox's width, so self hitbox 2 over 2. And then we're going to subtract half of the width of the text that's being drawn. And we do this by taking the text's length, and we'll cast it as an F32 because we are going to be multiplying it by a float. And then I'm going to come back and put parentheses around both of these because we need to cast it back into an integer. So 2.5 is just a hard-coded value in here that represents roughly half of the width of the characters that are being drawn. So for our y value, we'll do something very similar, where we take the y value of the hitbox as an anchor, and we will add half of the hitbox's height, so hitbox 3 over 2, and then we will simply just subtract 3, which is again another hard-coded value to represent the height of the text being drawn. So now that we have the x and y values, I'm going to come back in here and replace the calls to the hitbox and say x equals x and y equals y. And now if I save this, we have our text nicely centered in the middle of our button. All right, now that we have our button class fully defined, we're going to define a trait that will be implemented by this button class. So traits in Rust define universal shared behavior that can be inherited by many different structs. And basically, it's like an abstract implementation of some functions that a struct can come along and subscribe to, so that they also contain those functions. Functions in traits can either have a default value as defined by the trait, or when implemented by a struct, can be overridden to provide some custom functionality. For our trait, we'll be using a bit of both, and you'll see how we do that soon. So I will come down beneath our UI button and create a new pub trait called clickable. And in this trait, we're going to define a function to determine whether or not the mouse is hovering over a clickable item. So we will declare a new function called hover, which will take in a mutable reference to itself, as well as a couple of variables, the first one being hitbox of type tuple for i32s, and then we will take in two variables, mx and my, both of type i32, so that we can register the mouse's position. And then it will need a return type of option mutable reference self capitalized. And this return type is doing a couple of specific things for our system. Firstly, it's returning a reference to a mutable self, which is type agnostic, which means that any struct that inherits this trait, clickable, is going to be able to return a reference to itself without having to return a more specific type. And secondly, it's returning an option of that type, and the option enum allows you in Rust to either return some, which means that there is something to return, which would be a mutable reference to self, or the option can return none, which means that there is nothing there. And this is a nice way to have a null value in Rust. So you'll see how we use this in just a second here. So this function is basically just one check, which is going to be comparing the mouse's position against the hitbox values of whatever struct that inherits this. I will write this check out quickly. I'll say if mx is greater than or equal to hitbox.0 and mx is less than or equal to hitbox.0 plus hitbox.2, which is the x position plus the width of the hitbox. I'll do a line break and continue the if check, saying if my is greater than hitbox.1 and my is less than hitbox.1 plus hitbox.3. So if this check is true, that means that the mouse is hovering inside of it, and then we will write an else statement for when that is not the case. So if this is true, we will return sum self, which is the sum portion of our option enum. And if it is false, we will return none, which is the none half of the option enum. Okay, great. So this is the basic functionality that we need to determine whether or not the mouse is hovering over something. But we would like a way to be able to register that privately within the struct that inherits this. And what I mean by that is basically telling the button to draw differently when the mouse is hovering over it. So in order to do that, we're going to create another function in this trait called hover toggle. And this once again will take a mutable reference to itself, as well as a variable called state, which is of type bool. And no return type of this function, and for the default implementation, we can leave it blank, because this is a function that we intend to override in any kind of implementation of clickable. So to use this function, I'm going to come back into our hover function and call it twice in both sections of the if-else check we have. So I will say self hover toggle, and I will pass in the argument true. And then in the else statement, I will say self hover toggle and pass in false. All right, so this is the most basic implementation of the clickable trait. So now that we have this defined, I'm going to come down below it again and implement it for the UI button. So I will say implement clickable for UI button. And I could leave this completely blank, and it would simply inherit the two functions hover and hover toggle just as they're written. But I'm going to open this up so that we can override the hover toggle function and add some custom functionality specific to the UI button. So to do this, I declare the hover toggle function exactly how it's declared in the trait, but instead of leaving it blank, I will open it up and simply say self hovered equals state. And this hovered variable is the Boolean that we're tracking back up here in our UI button. So this Boolean will toggle between true and false based on whether or not the mouse is hovering over it. So in order to see that in our game, I'm going to come down to our button's color variables and change how they're defined. I am going to, instead of hard setting them here, I'm going to create a match expression for the self-hovered Boolean. And then if the Boolean is false, it will be how it is now. And if the Boolean is true, we are going to copy and paste our color values and simply swap them around. So white is first and gray is second. Okay, now that we have clickable implemented for the UI button, the last thing that we need to do is actually call the hover function somewhere in our go loop. So if I come back up to our go loop, I will create a new if statement. If let sum b equals state button hover, and then we will use the state button hitbox as well as the mx and my values that we created when we captured the mouse input. And I will open this if statement up for now, even though we're not going to put anything in there. The main purpose of this for right now is calling the hover function every frame inside of our go loop. So now if I come over to our game window and we hover over our continue button, we'll see that it is correctly registering the mouse's position and changing its color when the mouse is hovering over it. And finally for our button, we still click anywhere on the screen and the text toggles, so we're going to move our mouse input function into this other if statement. So if I cut all of this and simply paste it in here, now if we go back to the game window and I click anywhere on the screen, the text doesn't change, but if I click on the continue button, we have it properly functioning as a button. So one last thing I would like to show you how to do with this button struct that might be helpful for you is creating a private function for the button to register the click itself. So if we come back down into the UI button, I will create a new variable called count, which will be a U32, and the count will simply be a count of how many times the button is pressed. In our new function, we will set count to 0. And then in our draw function, we will create a copy of this text and change the text parameters so that it's displaying our count variable. And to do that in Rust, we use the quotations, open curly braces, colon, question mark, close curly braces, separated by a comma, followed by the variable that we want to track. So self count. And then we use a semicolon at the end. And then to make sure that the 0 isn't drawing directly on top of the continue like it is now, I'm just going to add 8 to its y value. Great, now we have the count displayed underneath the continue. So the last thing that we have to do is actually create a function for that count to increase. So down in the clickable trait, I will create a new function called click toggle, which will also take a mutable reference to self. And then in the implementation of clickable for UI button, we will declare this function exactly how it is in the trait. But instead, we will simply say self count plus equals 1. And now to call this function, we'll go back up into our game loop where we're looking for the hover and mouse input. And when they are both true, when we flip the toggle, we will also say b click toggle. And this b is the sum b that we have gathered from the hover check in this if let statement. So now if I come back to our game window and I click on the continue button, you'll see that number is increasing for every click that I do. Awesome. Well, this was an introduction to how I approached UI for my turbo game Dreamland. I hope you learned something, and thanks for watching all the way through. If you have any questions, feel free to come into the Turbo Discord server. I'll be happy to help troubleshoot anything from this video in there. In a future video, we're going to go over 9 slices and creating draggable elements with this UI system. So until next time, sweet dreams.